Okay, so we're looking at section 12.3. This is still surface area, and there are formulas that come with this. Again, I don't really teach very much with the formula because the formula can get really confusing to remember. Here is the principle about all surface area, and I don't know how you guys are going to remember this, but to me it's real simple, real straightforward. Find the area of each face, add them up. Surface area is area of front face, side face, back face, side face, and bottom face, and just add them up. So once you have your dimensions of what you need, it should be fairly simple to add those up. These formulas do simplify it a little bit if you can remember it. Surface area is equal to area of the base, that's what capital B always means, plus 1/2 times perimeter of the outside times the L, which is the lateral height. Okay, essentially what this 1/2 times P times L is giving you is the area of all four triangles there added up. So the idea of all pyramids are all the sides are going to be triangles. You just have to figure out what the area of the base is and then figure out the four areas of the triangles. In most cases, the area of the four triangles may be the same. So once you find one area of a triangle, you might be able to find the rest of them fairly easily. Okay, because if it's the same, then we just know how many triangles we have. But again, the idea of this is find the area of the base. Identify the base, find, and then find the area of the triangle, which is this portion right here. Okay, so you find the height of the triangle, the base of the triangle, and use that formula, and then you figure out the other ones around and then add everything up. So surface area is adding up all sides. Okay, for dealing with a cone is a little bit different, but it's the same idea. It's a simple formula. This is the formula you need to be able to use. We're dealing with circles, so therefore pi r squared, that represents the base. That's how you find the area of a circle, so that's the area of the base. And then the pi r L is going to give you the area of the outside of the cone around the outside. Pi being pi, r being the radius, and L is that slant height. Okay, from the top of the cone down to the edge of the circle, not the height down to the center. That does not really mean much for us unless we're trying to find what L is. Okay, but we need L. L is going to be your slant height is what we call it. Okay, or lateral height is also a term that we use. So this is the formula we're going to use for that. So let's just go ahead and get right into some problems and we'll go from there. Okay, so here we have an octagonal pyramid, which means the base is an octagon, and then the sides are always going to be triangles. So the lateral faces of a pyramid will always be triangles. So we need to figure out the area of the base plus all of our triangles. Now, it's regular, which means all of our triangles around the outside are exactly the same. So here's what our formula looks like. We find the area of an octagon will be 1/2 times little a times P, that's the apothem and then the perimeter, plus we have 8 triangles, so that's 8 times 1/2 times base times the height, and that's just the area of a triangle. So the area of one triangle times 8 of them will give us all the areas of the triangles, and then 1/2 times apothem times perimeter will give us the area of the base. So now we just plug in what we know. So surface area is equal to 1/2 times the apothem is given to us, it's 15.7, times perimeter. Perimeter is given to us in a sense that perimeter will be 13 because that's one side times the number of sides, which is 8, and that gives us 104. Plus, we have 8 times 1/2. We can just do that right in our head. So 8 times 1/2 is 4. Times the base is 13. Times the height, and remember it's the slant height, so that's 18. And again, all we're doing is just plugging these values in. So the first set of numbers that we get 816.4. The second set of numbers here, 4 times 13 times 18, we get 936. Add those two together, we get 1,752.4 feet squared. So that's what our surface area is for this one. Okay? So what I want you to do is do this one on your own. Same idea. A pyramid has 4 sides and it's a square pyramid. So try that one on your own, and then hit play when you're ready. Okay, so I got a total of 663,520 feet squared. Again, what I did was the area of the base there is going to be 440 squared. Okay, you have the area of the four faces is going to be 4 faces times 1/2 times 440 is our base, 356 is our height, so we plug those in. So you get this total when you add them up. Now, what you could argue, and actually legitimately argue, is that the bottom, the base, isn't really part of the surface because it is not there. It's on the ground, so we don't really see that portion of it. So if you were to only give this as the answer right here, I would totally be okay with that, especially if you can explain why you're getting that. Okay, but again, remember, surface area is the area of all the faces. In this case, if you said the bottom, the base would not count because you can't see it, then I would be okay with that. Okay, moving on, let's talk about some cones here. Cones are really easy because it's just a simple formula. Formula is pi r squared. That gives us the area of the cone, or of the circle of the bottom, plus pi rl. Okay, so what we do is we make sure that we know what the radius is. It's not 5, that's the diameter. So 2.5 is the radius. The L is 11.5, so we plug this in. So we have pi times 2.5 squared plus pi times 2.5 times 11.5. And again, you're just plugging this in. So we have 19.625 for the first one, plus 90.275 for the second one. Adding those up, we get 109.9 centimeters squared. Again, you're using this formula, pi r squared plus pi r L. Now, again, if you wanted to argue that the top of the cone cannot be counted as the surface because it's open. So most ice cream cones are open there. I would hope all of them are open on the center there for that circle. So if you did not want to count this and you only said 90.275, that's probably a more realistic answer. But again, you have to think your way through it. Surface means area of an actual surface. If there's a hole there and there's a gap, then you would not count that surface. So in this case, this probably would be a more realistic answer. Okay? All right, last one. Let's go through this quickly. Again, idea here is we want pi r squared plus pi r L. Then what we do is we plug in what we have. We have the radius, so pi times 15 squared plus pi times 15. But here's where we run into a trouble. You have to ask a little bit of trouble. You have to ask yourself, do you have what your L is? L is the slant height. We don't have that. We need to find that. Okay? So that's what we don't have. That's our missing piece. So we're going to use the Pythagorean theorem based on what they gave us. 20 squared plus 15 squared equals L squared. So we add these two up. We get 20 squared plus 15 squared is 625 equals L squared. Take the square root of both sides, and we get L equals 25. So we now know that L is 25, and that's what we can plug in for this right here. And again, we total these up. We get 706.5 for the first one. We get 1,177.5 for the second one. And then when we add these two up, we get 1,884 yards squared. Do not forget your units. We're dealing with surface area, which means our units is still square units. Okay, so hopefully these are pretty straightforward, make sense. And don't forget to take your Edmodo quiz if that has been assigned, and bring questions to class. See you then.